Thank you so much for having us. Behind me is, my backdrop here is an image taken by Tegan Moore of some of the microplastic fragments that came out of our study. And I'm just going to share my screen for a minute. So just in case people aren't familiar with the size and scope of the Great Lakes, this is a map showing the continent of North America with the Great Lakes highlighted in that red square. So you can see how large they are and also what kind of a role they fill environmentally in the region and indeed in the world as a whole. So what we're going to do today is to talk a little bit about our project, which started with sampling around the shores of the Great Lakes and then translated into a series of art projects and then into an exhibition, and then it will keep having further steps as we go along. So I'm going to kind of guide us through this conversation and keep bringing it back to the central points. But I will also put some links into the chats about some of the articles that we've published, our exhibition that's upcoming, and also our DIY guide to creating exhibitions with environmental awareness. So I'll put a copy of that directly into the chat. So today we have here Patricia Corcoran, who is professor of sedimentary petrology, microplastics pollution, and Precambrian geology at Western University. Kelly Wood is a photographer and associate professor of photography at Western. Heather Davis is assistant professor of culture and media at Eugene Lang College in the New School in New York. And Tegan Moore is an artist and project manager of the Synthetic Collective and the exhibition Plastic Heart Surface All the Way Through. And I am a professor of museum and curatorial studies at Western, and I direct the Center for Sustainable Curating there. So without further ado, I would like to pass it over to Patricia to talk a bit about the sampling study.
Thanks, Kirsty. So thank you all for having us here today. I'm just, as a scientist, I'm a little out of my element, so I'm going to try and explain exactly what we did and how it all started. And so the people that you see on the screen are obviously part of the Synthetic Collective. There are some other members who weren't able to join us here today, but we did meet and have a retreat. We rented a place by the lake, and it was a wonderful little place to stay, and we got to know each other a lot better. And it was Heather who actually, I remember she came up with this idea of what if we sampled plastic pellets across all 5 Great Lakes? And everyone thought it was a great idea. And I was thinking to myself, oh my, this is a really, really large undertaking. And just to give you an idea, I mean, Kirsty showed you a photo of the Great Lakes, but they represent 21% of the world's fresh water. They are extremely important for North America. And as she mentioned, for the entire planet, really. And so I thought about how we could do this. And as a scientist, I knew from my previous studies that most plastic debris, because it's so low density, it tends to accumulate with organic matter along the strand lines of beaches. And so we knew that our target would be the strand lines or the high water marks, where during stormy events, material is brought up. So you've often gone to the beach, and I'm sure as you walk along, you could see this organic material like sticks and seeds and other things. And what you may not have noticed is that there's often small pieces of plastic that are intertwined with this organic debris. And so we knew that that was our target. We also knew, or I knew, that there were many variables to consider. And so it was a study in which I thought we would compare the abundances of pellets with the location, so in which lake, because the Great Lakes are composed of 5 distinct lakes. Also surface water current movements. So how do those surface water currents move within each lake? How does that control the distribution of pellets on different beaches? We also had to consider how close our sampling locations were to tributaries, because rivers and creeks have been shown to transport plastic pellets into larger bodies of water. We also had to look at grain size of the beach. So some of the beaches were cobble beaches, some were very fine sand beaches, and we wanted to see if there was a correlation between grain size and the number of pellets and so on. So there were many variables. One of the variables that we had to consider was seasonality. And so the distribution of pellets anywhere in the world is going to depend on season. It's going to depend on storm events. So usually you have more in the Great Lakes, you would expect more pellets, or you would expect there to be a greater variation during the fall, as opposed to the summer when there aren't as many storms. And so we wanted to narrow that sampling time down, and the best we could do was a 2-week window. And in order to get to all 5 Great Lakes within 2 weeks, we needed to have a number of samplers. And so we had 13 samplers. We had 2 for each of the smaller Great Lakes, and then we had 5 for Lake Superior, which is the 2nd largest lake in the world. And so it took a while to get these pellets. So we did break off in pairs because in terms of sampling, we always have to work, or field work, we always have to work in pairs for safety reasons, even though we were just on beaches. And it all started with Tegan and Kelly Moore, who were on Lake Huron. So that's the 2nd largest of the lakes. And they started at a beach called Baxter Beach. And Baxter Beach is located near a city called Sarnia. And Sarnia is actually a place where much of Canada's plastics industry is located. And this is where they make the pellets. And so from a previous study that we'd done, we knew that there would be many pellets in the Sarnia area. And they decided to start there, which was very interesting because I had decided that the quadrat in which we would sample was 20 meters by 1 meter. So what we did was we'd string out a tape measure for 20 meters along the Strandline. And then within 1 meter of that tape measure, we would collect any plastic particles, not only pellets, but all kinds of plastic particles that we would find. And I got a phone call, I think it was Kelly that I spoke with, who said, you know, it's been 2 hours and we've only moved 2 meters because there were so many pellets. And so we had to change the size of the quadrat down to 10 meters squared. So basically every beach, we went to 66 beaches and we sampled over 10 meter square areas on each of these beaches. And then what we did, the sampling involved, if the sand was sandy and it was very dry, we used sieves. If it was wet, or if the grain size was very fine or very coarse, like cobbles and pebbles, then we would just pick by hand. And in the end, we collected 10,595 pellets, and each pellet had to be characterized. And what that means is we brought all the pellets back to the lab here in London, Ontario, and we measured the size of each pellet. We also took note of the color, the degree of chemical weathering that has occurred, any surface markings, and we had to put that all into a database. So we had this huge database of information. We also had the lake name and the coordinates, latitude and longitude coordinates. And so in the end, we were able to determine the factors that are really controlling the distribution of these pellets throughout the Great Lakes. But from that, and for me as a scientist, I would take all that information that's in the database and create these scientific figures and graphs and things like that. And then we had it published so that everybody who was involved was actually a co-author on a scientific paper. And so that's kind of where the science part of it occurred. And I could go on for hours and hours about the whole story, but I won't, because I know you're really interested in the artistic part of it. So that's my chunk.
Thanks so much, Patricia. It was very exciting for us as artists and curators and writers to be sampling in the sand. I think it was a very different experience. I'm now going to ask Heather Davis and Kelly Wood to talk a little bit about the artworks that they made following the sampling project. So Heather, go ahead.
Yeah, so thanks so much for having us here. So Kirsty and I created some artworks together, but because we're both researchers rather than rather than artists, they're in the form of a kind of textual documents. So I'm going to see if I can show you them, just because I think it has a more robust effect in this way. So this is based on the research that Tegan did. So part of this, all of this research is really about trying to investigate and make visible all of the types of plastic pollution that are in the Great Lakes region. So this is the list that Tegan managed to compile of all the known plastic producers in the Great Lakes region. And the reason why I'm showing it to you is because I think it gives a sense of the kind of overwhelming nature of the amount of plastic that is produced in this region. And so this is one of the posters that we created. The second one, if I can make it go, is all of the known chemicals associated with plastics packaging and known polymers produced in the Great Lakes region. So again, I think it has this kind of overwhelming effect of really bringing to light all of the ways in which all of these chemicals are seeping into the environment, into our bodies, and that actually there hasn't been a lot of research done on these topics, especially in the Great Lakes region, which is the reason why we did the pellet study together. But we also wanted to think through not just the kind of like effects or the things that were already there that we're kind of grappling with and trying to make visible in order to both sort of raise public awareness, but also hopefully push a little bit at some of the policies that govern these regions. So part of that also involved us looking into the major legal agreements and treaties in the Great Lakes region. And I know that for myself, I don't know if Kirsty, you want to add anything, but I know that for myself, this was a real eye opener because this region of the world obviously is governed by all kinds of sort of different treaty relations between the officially recognized nations of Canada and the United States, but also all of the First Nations communities that are in and around the Great Lakes region, which both Canada and the United States have official and unofficial treaties with. And so this is a kind of compilation of all of the ways in which that water is governed and managed. And by including some of the treaties that Canada and the United States have with Indigenous nations, we were also trying to point out the ways in which there are different legal systems and different legal governance structures that should pertain to these regions and that have been pertaining to these regions since time immemorial, and that perhaps better partnerships, better forms of Indigenous sovereignty might lead to a more beneficial outcome for everybody. And then finally, the last kind of component of the artwork that we produced as part of the exhibition that really, again, came from this huge body of research that we have been involved with for the past 7 years, is these type like index cards that are based on Lucy Lippard's numbers show, and they were in a certain way a kind of counterbalance to some of the kind of overwhelming nature of the kind of factual information around the Great Lakes. Instead, they are kind of possibilities for future proposals. So some of these things are already in the works, or some of these things have already actually happened. But some of them are trying to happen, but have not yet. For example, there was a piece of legislation that was passed for Lake Erie to be recognized as a person, but then now that's being challenged through the courts because of the ways in which industrial farmers are concerned about the effects of what that would mean upon their livelihoods. And so the other thing that's really important to mention about these cards is that we had this amazing research assistant named Jess Park, who collected air pollution from the New York City subways and turned it into an ink that she then used to print these cards with. So, you know, in our exhibition planning and making, we're trying to think through both how to kind of think about the sort of factual information and convey that in a way that is compelling and interesting to a broad public, but also think about the form of that. So how can we do this in a way that that both highlights, but also has this kind of embedded principle of sustainability within everything that we do. So I'm gonna stop there. And Kelly, you can talk about yours.
Thanks, Heather. I'm Kelly Wood. I'm a photographer, and I've been working with the subject of garbage and specifically plastics for some decades now. I did work on the scientific survey of the lakes, and I worked on Lake Ontario with Kirsty Robertson. And actually experiencing the scientific sampling process was integral to my understanding of art making that came later. The scientific sampling of the lake can be seen as quite analogous to the kind of sampling that I did for the new collage series I produced for Plastic Heart, the exhibition. I sampled images from the internet, sort of crowdsourced imagery of plastic pollutions in the Great Lakes, all the Great Lakes, in the very same way that we sampled the actual microplastics from the Strandlines, in a way. So with the scientific survey, we sampled pellets from the lake, and from the art, I sampled plastic pollution images of the lake from the internet. I amalgamated the crowdsourced imagery a lot like the pellets were collected and sorted. My artistic survey or study amounted to narrative collages, not a set of data points, but rather a visual convergence of a different set of data. So Dr. Corcoran's data sets get amalgamated and mapped, and the survey sample forms patterns from which the scientist can make sort of inferences. And I found that very similar to what I was trying to accomplish as an artist. The raw visual data needed to be brought into some kind of interpretation, and inferences drawn from there. So in my view, what I did as an artist really tracks along well with the scientific study in real ways, and the collaboration between the art and science feels really mutual and very consistent. And I think that not just my work, but most of the art in the Plastic Art exhibition supports the evidence that the science revealed in similar kinds of ways. And I don't know if I'm allowed to show rather than just tell, but I could show you one. I'll give it a try. See if I can share my screen. Yeah, so this is just one sort of example of the kind of the images I sourced and brought together. It kind of shows the lake sort of upside down and turned over, and that's just a quick teaser. Here's a kind of another one. So these are all kind of lake images, and that's I want to be quick, so I'll just stop there. Thank you.
Thank you so much, Kelly and Heather. And our final presenter today is Tegan, and it was really hard to ask Tegan what to talk about today because she has been so integral to every part of this whole project, from working with Patricia to sample and characterize the pellets to making her own amazing artwork for the show. But we thought it would be useful to talk about what we're doing as next steps. So Tegan's going to talk about our solar website that accompanies the exhibition. And while she's talking, I'm going to place our a Padlet into the chat. So this is like a methodology of collaboration that we actually haven't used as a group, but that is becoming a really popular way of thinking about how to work together in online environments. So Tegan, go ahead.
Hi, everyone. Just going to quickly share my screen. Okay. Yeah, so my name is Tegan Moore. I am an artist and settler living in Tiohtià:ke, unceded Indigenous land known as Montreal. Um, I'll be introducing just a short summary of the research and tactics behind our experience building a DIY solar site, along with designer Anna Eiler and coding by Jean-François Robin. So what you see in this picture here is the site, which may or may not be live at this moment. It's overcast in Montreal. But this is our secondhand solar panel and Raspberry Pi set up at Kelly Jazvac's studio, another member of the collective. So some of the problems we were thinking about when doing the research in developing this site, which is a very simple site, but it has a purposeful simplicity. We were thinking about internet content and activity becoming increasingly resource intensive. Storage capacity continues to increase, and so do the limits on accepted file sizes in correspondence and also in web pages. So heavier websites not only increase energy use in their network infrastructure, but also shorten the lifespan of our computers. Visual culture is a major player in this form of consumption through its frequent use of high quality images and videos, and especially with the recent onset of more online programming. So where broadband connectivity is high, it's often taken for granted. So we're hoping with this work to challenge expectations for constant connectivity. So building and experiencing a DIY solar powered website necessarily involves an awareness of the energy that powers it. So our aims with this site was to build a website with its own energy storage, powered locally and off-grid, to radically reduce the energy consumption of accessing the site's content. To do so, we first focused on building the smallest site possible, a requirement for the storage capacity of this small DIY solar server. And to model a low bandwidth site, which de-stresses storage loads and makes the site more accessible in places with slow internet speeds or limited data. Some of our methods were to make the site a static site. So most websites are dynamic sites, which means they use programming languages to generate the site for every unique visit. And the static site instead lives on the server's hard disk, which requires much less processing power to load. We focused on findability, so making sure that the content is easy to find, resulting in fewer server requests. We worked specifically on images, which can really weigh a website down. So making images as small and light as possible, including the file size. We've dithered them and worked with them in black and white or monochrome. We also worked with default web colors and also default browser text. So many sites require a font family declaration to access a custom font, which is another request to the server. So instead, visitors to the site will see a default typeface of their own browser. So this is just a quick image comparison of two images of the same dimensions and how small we were able to make them using these methods. So beginning with an image that was 520 KB, we ended with an image that's 29 KB. So that's just a quick example. And I'll quickly show you the site. This morning it was at 5%. And we wanted to make sure that we had some indications on the site that would explain the conditions of viewing it. The site, Kelly Jasvek has actually remarked that it has her ideal life. It wakes up around 11 a.m. and then it goes to bed around 9 at night. And it's very much responsive to its site. So the weather in that location and the specific conditions of where it sits. So we thought, you know, in thinking about materiality, like we think of the internet as being kind of immaterial, but there's many material implications that sort of bring it to a page. So we wanted to really think through what those materialities are, and bring some questions up around its energy use and subsequent materialities down the chain. So there's a weather report, a live weather report in Montreal in the top corner, and then a battery level, which refreshes constantly. So that was about an hour ago, and it's still at 5%, luckily. So yeah, so that's that. And I just want to quickly point out some resources that were really helpful for us when building this site. Some of you may have heard of this. Low Tech Magazine has a solar site along with a ton of information about how to build one, and also thinking through how sustainable it is, and really thinking through a lot of the questions of how it actually is sustainable. Okay, that's it for me, I think.
Thanks so much, Tegan. So we will end it there. If you'd like to know more about the Synthetic Collective, I've put our website in the link, as well as some other resources. We're happy to answer questions in the chat or on the Padlet that I posted, but thank you for listening.